Hello, Math 126 students. Going to make a short video just about pages 1 and 2 of the final exam. Just do more of a review here rather than work through problems. So pages 1 and 2 of the final will focus on chapters 12 and 13. So let's just talk about that. So I went through and I looked at the 4 most recent final exams, and this is what I saw. I saw questions. Some of these had multiple choice, but the things that pertain to chapters 12 and 13, there were vector operation questions, questions about cross products, dot products, projections. There were questions about 3D shape names. There were questions about finding the tangent line for a 3D curve. There was a question about curvature. There was a question about surface of motion. There was a question about finding a tangent line. There's more vector operations. There was questions about finding equations for lines and planes. There was a curvature question. There was a question about lines and planes. There was parameterizing a curve of intersection. There was translating distance. So there's just a little bit of a snapshot of some of the things from recent old finals. That's not saying those things will all be there, but those are things I definitely want to talk about briefly in this video. Make sure you don't forget what they're about. So I've broken it into 4 things. Questions that have to do with vector basics or foundations, questions that have to do with lines and planes, questions that have to do with just curves in 3D in general, and then talking about measuring things on 3D. So I just want to say a few words about each one of these topics. So this is from my final exam review. We're not going to hit everything here. I'm just trying to make a short video just to so you don't forget a few things. We learned how to find the magnitude of a vector. We learned how to rescale vectors. We learned how to make something a unit vector. We learned how to add all these things. So we should have a visual, things that you should have a visual for, I would say, if I was making a note sheet, is I'd have a visual for these things. And I've given those to you before. But if you've forgotten, let's do it. Like I said, I'm trying to do it quickly, but a quick recap. If this is U and this is V, what we do is we move V and put it over here. And then we call this the vector sum. That's U plus V. Similarly, we talked about if you have U and V and you draw them tail to tail, so same 2 vectors, then this vector that goes from here to here is U minus V. So those were 2 observations we had. We saw occasionally that we needed to use projection, and projection was if you drew them tail to tail, and this is B and this is A, there were 2 questions we asked. One was, how long is this? So if you come straight down and form a perpendicular, what is the length of this? And that ended up being A dot B over the magnitude of A. We called that the component projection. It's just a length. It's a number of B onto A. And then we said if you actually want the vector itself, you can use our rescaling trick. So if you wanted this vector, you could rescale by doing the following. Take the vector A, make it a unit vector, and then multiply by your desired length, which is this. And we called that the projection vector. And that formula can be written a few different ways. Beyond that, there were a couple big facts, which is that the dot product of 2 vectors is the magnitude of U times the magnitude of V cosine of theta, and that the cross product is perpendicular to both of them, and also we have this fact about its length. So a lot of those old finals that have to do with multiple choice or vector facts, they have to do with this. Do remember you can check your cross product. Okay, that's all I'm going to say about vector basics. Let's keep going. So lines and planes, that's a big topic. You can pretty much expect there's going to be a lines and plane question. Typically when I'm one of the instructors, I always like to make sure we ask about this because it was a big idea. So back when we talked about this, whenever your question says find the equation of a line, the first thing you do is this. Now, I don't always use T. Sometimes I use a different letter if T is already in use. And then your job is to find 2 things. You need a point, and whatever that point is going to go here. and you need a direction vector which is parallel to line, and wherever that's going to go is there. Now what happens in these questions is you have to read carefully. Sometimes the information is given. That requires you visualize a little bit. Like if they give you a plane that's perpendicular, you might have to draw that. If it's not given, then typically what we do is we find 2 points and we do 3 subtractions, and that gives us our direction vector. To find the equation of a plane, what we need is a point and a normal. And the first thing you do is you write this in, and then you start filling in. And you have to understand when the information is given, or you're going to find 3 points, or equivalent, you're going to find 2 vectors that are on the plane. That's really our strategy back when we did this. This was a big topic that we spent a couple days on. And then you're going to take a cross product of those 2 things to get your normal vector. I had a big review sheet I handed out. You can still find that on my materials page. Got to be ready for that topic. Curves in 3D. So first we had some basics. We talked about where curves came from. Sometimes I noticed that on a few old finals, and sometimes students ask about that. So just a quick reminder, we also had this on exam 2. If somebody gives you this, a good way to parameterize it is to say cosine of t, y equals sine of t. Now if the constants are different, let's say you have well, what am I going to do? I didn't plan this. Let's say you have something like x squared plus z minus 1 squared equals 9, and you have y is equal to 3xz. Once again, you have a circle, and so you would say x in this case is 3 cosine of t, and you would say z minus 1 is 3 sine of t. So if there's a circle, use that. And then you would need to rearrange. This is z equals 1 plus 3 sine of t. And you would say y is 3 times, I don't know why I used a 3 here, x, which is 3 cosine of t, z, which is 1 plus 3 sine. So that's parameterizing, is the idea. If there's a circle, parameterize a circle, and then substitute into the other to get the equation. Sometimes we ask, I had something like this on exam 2. That's that game. This is what we talked about, sort of where curves come from. And then we talked about finding the tangent vector. So if you do have a curve, this one, 3 cosine of t, just as an example, and whatever it is, 9 cosine of t. I did not plan this, so sorry, this is kind of a messy example. And z is 1 plus 3 sine of t. So that is one parameterization for this intersection. But if the question was asking you for the tangent vector, you just take the derivative of each component separately. If it wants the unit tangent, you take that vector and make it a unit vector. And if it wants the tangent line at a particular place, then you're finding a line. And you need a point, and you need a direction. I'd have to tell you t. For example, if I told you t was 0, you'd plug in a 0 here, and this would be 3. This would be 9. This would be 1. And then you'd have to take the derivatives and plug them in and get that. So there's a tangent line. Okay, we played that game. So then we went in more depth about 3D curves, and there were lots of measurement tools. This is a big part of the test where I just would make sure I had these on my note sheet. We talked about arc length, which is pretty much a straight computation thing. We talked about curvature. I find quite a few times when curvature is asked in the final, students have the wrong formula on their sheet. I'm not sure why. So make sure you have this. So once you have a curve, or they give you a curve, whatever, if you need to compute curvature, you need to compute the derivative. And there's lots of ways to get points here, even if you're stuck. Curvature is a whole new function you get. So find this, find this. The worst part is almost always then doing the cross product, and the bad part is usually you have t's floating around. Then get the formula. But at the end of this, you're going to have a formula for curvature. Sometimes we ask you to plug in a number. Sometimes we ask you something about the formula. That's curvature. Arc length is just plug and chug. It's not great. You know, if we ask you for an arc length, the object under the radical must simplify. And in terms of acceleration, there were a couple things we did. One was we did problems where you started with the second derivative and you did antiderivative, antiderivative. We did that on exam 2. The other was we did the tangential and normal component of acceleration. Don't let that scare you. Just remember that formula put it on your note sheet, because that should be kind of gimme points, and you wouldn't want to miss that. And those are here. We did not ask you to compute this, so you can ignore that. Okay, so there's a recap of chapters 12 and 13, the things you need to know. At this point, you could click on any of the old exams. I don't know if I'll include this in the video. Let's take a look. So let's click on one older one, and you could just sort of say, do I know how to start pages 1 and 2? Find the equation of the plane. Ultimately, this is a point of intersection, but now I would start to do whatever process. So consider this plane that goes to those points. So if I was taking this test and I was stuck, I would find the equation of that plane. And then I would read on and see what needs to be done. So that's finding the equation of a plane. Okay, here's the acceleration. I know I'm going to do antiderivatives. So to me, those are problems. Even if you're stuck, there's a lot of things you can do. Find the equation of the plane. Find the tangent plane. That's actually a chapter 14 question. Let this be the surface. Find all the points when this curve intersects this. Okay. Find when the path. Okay, so that's actually a curve question. I'm going to leave that though, and we'll leave specific questions for class. All right.